Section 7.4, day one notes, essential question, how do you find an inverse of an exponential function? Okay, we're going to start talking about logarithmics. Okay, and they give you some examples to kind of get you started on this. Some easy ones, some difficult ones. Well, 2 to what power gives you 4? 2 to what power? What's x? Well, first one, x would equal 2. Okay, 2 to what power gives you 8? That's pretty easy. 2 to the third power gives you 8. Okay, but the last one, 2 to what power gives you 10, is a little bit tougher to do. Okay, and what we're going to discover is how to solve for that. Okay, on the next one is the ones that aren't perfect, because there's no perfect integer number that 2 to that power will give you 10. Okay, the definition of a logarithm with the base of b. This is a really important formula that you're going to have to memorize and be able to apply and be able to use. Is log base b of y, how it's written, equals x is the same thing as b to the x equals y. Okay. Just basically how it changed from an exponential function to a logarithmic function. Okay, because they have a relationship. Basically, what log does is it finds the value of the exponent. When you want to find the value of exponent, you switch from exponential form to logarithmic form. And it's written as log base b, whatever the base is, the big number. The x is the exponent. What it's set equal to is your y. Okay, it'll take a while to get used to. Okay, so the first one, how do you rewrite these from logarithmic form to exponential form? You take the base, which is this number right here, the 2. Then you take the power, which is this number right here, which is 3, and you set it equal to 8. So 2 to the third power equals 8, which is true. Okay. You go to the next one. Base of 4 to the 0 power equals 1. Okay. And just using the same formula over and over again. Okay. And all these make sense. 4 to the 0 power and 8 to the 0 power equals 1. This one, 12 to the first power equals 12. So we're going to write 12 to the first equals 12. Or I'm going to write that again, maybe a little bit better. That's a 1. Okay, and the last one, 1/4, oops, 1/4 to the -1 equals 4. Okay, so you can see on all these, you take the small number, which is your base, you set it equal to the exponent, which is what it's equal to, or you set that as the exponent, what it's equal to, and then the number you set equal to is the whole number right there, that big number. Okay, so base to what it's equal to, or to the power whatever it's equal to, is equal to this number. Okay, and it'll take some while getting used to, but it should make sense. You always check your work after you're done. Okay, because I can't write this good. That's probably the best one to write. So let's go on. Okay, now we're going to evaluate the logarithm. Okay, so how you can rewrite this, if you want to, is the base. We don't know what it's equal to yet. Okay, so you can set all of these equal to x if you want to, if that makes it easier. Okay, and then we're going to solve it. 4 to the x equals 64. So we write 4 to what power gives us 64. Hopefully you know from our last section, since we did a lot with cube groups, you know that 4 to the third power equals 64. So log base 4, 64 equals 3. Okay, same thing here. 5 to what power gives us 2? Or sorry, let's start over. 5 to what power gives us 0.2? Well, it might be easier to change 0.2 to what? Wow, I'm having issues here. It might be easier to change 0.2 to its fraction. What's 0.2 as a fraction? Well, it's 1/5. Okay, so what's the relationship between 5 and 1/5? Well, 5 and 1/5 are reciprocals of each other. Well, what do we know? How do we get a reciprocal to a power? Well, we raise everything to the -1 power will give us a reciprocal. So that way we know that x equals -1, because 5 to the -1 will give us a reciprocal, which is 1/5. Okay. The last one, 3 to what power gives us 9? Okay, well, that's easy. 3 squared gives us 9, so x equals 2. Okay, so it'll take some practice getting used to that, but that's how you solve those. Okay. Okay, we're going to talk about common logarithms and natural logarithms. Okay, first, if it's a common logarithm, if you just write log x, it's going to assume that the base is 10. So 10 to what power gives you x, okay? It's a logarithm base 10. Not all logarithms have the same base, but if you just push log in your calculator, it's going to have base 10, okay? Now, a natural log, remember this ln, I know the ln is backwards from nl, but that's how it's written. Ln x is equal to log base e, which we just learned about e last section. So log base e of x is the same thing as natural log of x, okay? It has a base of e. So a lot of these you can just put straight in the calculator. So for example, evaluate using the calculator log 8, you can just put, you can just hit log 8. I don't know if you have to close in parentheses, but I will. Okay, hit enter, and you get 0.903, okay? Oops. Oh, here we go. Okay. We get 0.903. Okay. And on the next one, we have natural log of 0.3, which we can just put that in our calculator. And natural log button is right below that. And what was it? 0.3? 0.3. If you close the parentheses you want to, I don't think it really matters. You get negative 1.204 if you round it to the third decimal spot. Let's just do that. Negative 1.204. Okay. And that's pretty much it. Evaluating on the calculator is pretty simple. We're going to do a lot more with logs, but right now it's pretty easy. Okay. So find the inverse of a function. Okay. Well, this is the same as what we did in chapter 6 when we found the inverse. The first thing you're going to do is switch x and y. Okay. So we're going to write it as x equals 4 to the y. Okay. Then what we're going to do is use the logarithm exponential change function to change to a logarithm. Remember, if it was log base b of y equals x, then it was the same thing as b to the x equals y. I know that's written pretty bad. So that's what I'm going to do. I'm going to rewrite it in exponential form. So log base b, my base is 4, because that's my base of the exponent, of y. Well, y in this case is x. I know that's confusing, but it's set to what equals. So log base 4 of x equals y. And now I have y solved for. And if you look about it backwards, 4 to the y power equals x. You always look at the base to the power what it's equal to equals x, which means the same thing. So our answer will be log base 4, and I'll try and write this a little bit clearer. Log base 4 of x equals y. Okay. The next one, okay, what I like to do, first thing to find the inverse of a function is switch x and y. So we're going to switch x and y and have it as x equals the natural log of parentheses x plus 3. Okay. Then from there, okay, I'm going to switch, that should be a y. I'm going to switch x and y, so it's going to be x equals natural log of y plus 3. Okay. And the next step is I'm going to rewrite it. I think it's easier to just rewrite natural log as x equals log base e, because natural log is the same thing as log base e. We learned that in the last section, of y plus 3. Okay, I know my writing's sloppy. I'm trying to get better. All right. So then what we can do is, okay, log base e of y plus 3. Hopefully everybody can see that, y plus 3. Okay. So next what we're going to do is take our base to the what it's equal to and set it equal to what's this left and get rid of the log. So we can do e to the x equals y plus 3 by rewriting the exponential form, rewriting it from exponential, or sorry, logarithmic to exponential form. Okay. From there, we just need to get y by itself by subtracting 3. So we subtract 3 from both sides, and we end up with e to the x power, or e to the x power minus 3 equals y, which would be the inverse of that. Okay. So again, just being able to, the first step is to switch x and y. And then if it's an exponential form, write it in logarithm form. If it's in logarithm form, write it in exponential form. Okay. Pretty easy just rewriting it. Well, not easy, but it takes some practice to get used to. But you really got to understand how the base, what it's equal to, and then what the number over here, how the relationship always goes. Okay. All right. So this is your exit slip. Remember on this one, if log does not have a base written for it, it's log base 10. So you could write a 10 in there if you need to help yourself out. Okay, remember switch X and Y and then rewrite an exponential form. Good luck. If you have any questions, email me, and that is it.